Okay, Assalamualaikum warahmatullahi wabarakatuh and very good morning. So today we continue with chapter 6, I guess. Okay, the PST 104 Basic Natural Rubber Processing. In chapter 6 we cover on latex coagulations. Okay, here's the course outlines of this chapter. Basically we will cover on methods of coagulation. And secondly, we will cover on coagulation of latex procedure. So I think there are about 5 coagulations procedure that we cover in this chapter. And there is some URL over here. You might want to see this URL later on when you have this slide. Make sure you copy this slide and go to this video. And it will give you some idea how the coagulation appear in a latex field. And this is some sort of the illustration coagulation model of rubber particle in latex by protein. As we know that rubber particle coated by the negatively charged on the outer layer, and by additions of the positive charge and the protein, it will tie the rubber together and eventually will be coagulated the rubber. Okay, this is the figure illustration of processing to obtain concentrated latex at the main natural rubber commercial forms. Okay, so basically any natural rubber will be collected either any natural rubber will be collected from the rubber tree itself. As we tap the rubber tree, produce a latex, okay, and the latex will be further divided by 2, which is with stabilization to maintain the natural rubber latex in equal solutions or in latex forms, or we have auto-coagulated. So we go through the first area, which is the left hand side. With the stabilization, you will have what we call that the free latex with significant amounts of anticoagulants, and we go through the centrifugation to produce a concentrated latex. With concentrated latex, you need to preserve with either the high ammonia or low ammonia to contain it before you can produce a final product. Or also with the latex that you have, the stabilization of latex, and then we go to the coagulation process, go some sort of the rolling to remove the byproduct water, etc., to produce a sheets. Here we have RSS, rib smoke sheets, and hot air sheets we call the air dry sheets. Yeah? And other than that, autocoagulated also can be produced, can be used for crimping, granulating, and drying. Whereas for natural coagulation, autocoagulated rubber, or we call the cup lumps ataupun pegetas scrap kita panggil tu, you go through the washing, crimping, granulating, and drying to produce either the rubber sheets, rubber crimp, or the technically specified rubber. Okay, and this rubber will be produced to produce SMR, which is called the standard nation rubber itself. Okay, the last lesson outcome for this chapter, at the end of the chapter, you should be able to list and explain the method of NR latex coagulation, to differentiate the coagulation techniques in terms of their procedure, advantage and disadvantage, and finally to determine the amount of acid used for coagulation. So as we know, you need different amounts of latex depending on your DRC content, and the other one is depending on the pH of your preserved latex itself. So it's strongly dependent on your anticoagulants or that you use for preservation. If you have used ammonia, but probably you use more amounts of acid for a coagulation process. Okay, the coagulation or destabilization can occur for many reasons. The main one being a decrease of a pH of latex promoting particle-particle aggregation. Other mechanisms were proposed to explain latex coagulation. The neutralization of anions and particle membranes liberated by hydrolysis of some lipid compounds, and the divalent cation present in latex. And finally, the formation of link between the particle due to action of heavier protein present in latex. Okay. We move to the methods of coagulation. Okay, basically, I did mention earlier we have 5 methods of coagulation. The first one is very common, which is the acid addition, and then we have the assisted biological coagulation. We have autocoagulation, also very common, which is the naturally coagulations in a field, and then we have a continuous coagulation, and finally the heat gelation. For acid coagulation, the most important method coagulation is the reduction of the Z potential by the additions of acid, and this may be done in a 3 ways. Okay, the first one is acid addition. The second one is carbohydrate addition, acid development known as assisted biological coagulation, and the third one is autocoagulation, which is natural acid development. This one involves the microbial attack. Okay, zeta potential is one of the key properties of the particle that can be affects the natural stability as well as the cell adhesion. Zeta potential, which is a positive or negative value, have a significant role in stabilizing the particle suspension. This is attributed to the electrostatic repulsion between the particle with the same electric charge that cause segregations in the particle. Okay, previously I did cover on the latex stability. Okay, we know the zeta potential affecting the stability of latex, as we have what we call that the zeta potential of negatively and positively charged, which is balanced. We will have most what we call natural condition, which is the most condition favorable for what we call stable latex. Okay, as one of these charges increase, it will affect differently. Okay. The acid addition, natural rubber latex is usually coagulated with formic acid or acetic acid. Okay, in practice, formic acid is used predominantly for preparation of rib smoke sheet, ADSA dry sheet, scripts, and most of the block rubber prepared from latex. Whereas for sulfuric acid, which is stronger than formic acid, is avoided due to the adverse effect on color, PRI, and cure rate of rubber, except for skim, PA18, MG30, and coagulation. Usually, you will focus on the mild acids rather than the strong acids. Okay. Acetic acid is weaker than formic acid, okay, and it is used for confine the partial coagulation of the yellow fraction in the preparation of pale crisps. Okay, untuk produce latex yang color dia cerah, rubber color dia cerah, you will use the acetic acid, which is slightly weaker than formic acid, and will not discolor the rubber produced. Acid should be diluted to about 3% weight over volume before adding into latex. The pH coagulation is around 5 to 5.2. Although the lower the pH is better for coagulation, however, you need to remember as the lower pH will indicating the darkenings of the rubber itself. So you don't want to impart on dark color of your rubber. Coagulation is complete after around 6 to 10 hours, depending on the volumes of your latex that you want to coagulate, and depending on the pH of your preserved latex, and also depending on the type of acid that you use. For acid addition, how it functions actually, the hydrogen ion from the acid neutralize the negative charge of the surface of the membrane. As we know, the negatively charged makes the rubber membranes to be stabilized as they repels to each other. And then the particle become neutral and come closer and collide with one another. When these neutral particles collide with each other, the outer membrane layer breaks up, the rubber polymer are set free. So this is the illustrations of the how the acid addition imparts on the coagulation. When the diluted acid is added, H plus ion from the acid neutralize the negative charge on the surface and protein membranes. Okay, the rubber particles are neutralized no longer repel to each other because of negatively charged ion being neutralized. The free moving rubber particles collide with each other. The thin protein membrane breaks, the rubber molecules are free to move and they tend to entangle and clump together. The latex have coagulated. So this is the basic illustration or concepts of the acid addition to promote a coagulation in free latex. Method of coagulation of natural rubber latex. Okay, a method for coagulating a natural rubber latex which comprise adding one and acid and two at the least one salt selected from the group consisting calcium salts, ammonium salt, nitric acid, sulfuric acid, carbonic acid, phosphoric acid, hydrochloric acid, and formic acid, and or a polymer coagulating agent, natural rubber latex, under agitation, and thereby form a porous coagulated rubber. The above method for coagulating of natural rubber latex allow a high-speed coagulation and continuous operation, which result in the reductions for the operation cost and equipment cost for the coagulation of natural rubber latex. The properties, PRI, or we call the plasticity retention index, the ratio of plasticity number measured after air oven aging under specified condition to a plasticity number measured before aging. PRI indicate the resistance to oxidation process of rubber where the PRI value is needed for longer shelf life of rubber. Untuk storage, okay, you need high PRI value for longer shelf life. Okay, the cure time, the preset time needed to complete the curing process of rubber. PAAT, the processing its rubber, concentrated master batch blend of vulcanized rubber, which is 80 parts, and raw rubber of 20 parts, which from superior processing rubber, which allow consumer to obtain any desired degree of superior processing character in almost any types of rubber, natural or synthetic. And then we have MG30, methyl methacrylate grafted rubber, 30% of content methyl methacrylate, one of the specialty NR rubber, which have both plastic and rubber characteristic. Okay. The second process is assisted biological coagulations. Latex coagulates spontaneously in about 48 hours. Okay, this one is a longer process compared to the acid coagulations. By the acidifying action of the adventitious bacteria and yeast of the indigenous substrates. The times to natural coagulation can, however, be reduced by adding a carbohydrate substrate such as molasses for proliferations of microorganisms to promote rapid growth of the microbes growth. This is the assisted biological coagulation ABC process. Okay, that's why we call the assisted biological coagulation ABC process. In this process, molasses containing 50% weight over weight of carbohydrate, so you introduce more carbohydrate. A byproduct of sugar refining industry is added at the rates of 0.8% weight over weight of the RC. So you need to know the actual amounts of your RC, and you add 0.8% of the what we call that, the molasses. Okay. As the substrate to acid developments by the bacteria. As we know, the highest the carbohydrates is promote better growth of the bacteria itself. Okay, the ABC process requires about 16 hours for coagulation and considerably longer for latex containing anticoagulant, or treated with hydroxylamine hydrochloride for viscosity stabilizations. Thus, in its original form, ABC process was found to be not quite satisfactory. However, this difficulty has been shown to be overcome by adding small amount of surfactant, which is diiodized sodium sulfocyanate, which is at 0.1% of the RC of latex, to the fresh latex containing of 0.4% of molasses. Addition of either some inorganic salts or surfactant resulting in reducing coagulation time under ABC process. So if you want to reduce the coagulation times, you might consider adding some of the surfactant or inorganic salts. Unammoniated latex can be satisfactorily coagulated in 8 hours in the presence of 0.4% of molasses and 0.1% surfactant, with the resulting of rubber being fast cured. Okay, some of the industry demands that the latex collected in a field were not preserved. Okay, unammoniated latex. Okay, before the ABC coagulation process being introduced. So if the industry using the ABC process, they want your rubber is unpreserved or unammoniated. Okay. Bacteria or microorganisms, the lowest form of a living cell, are present in the atmosphere, and when the tree is wounded during the tapping process, the latex that flow provide probably one of the best grow media for the proliferations. After several tapping, microorganisms colonize along the length of the previous tapping cut and in the cups. Furthermore, the tapping knife acts as a bacterial carrier and is used to tap many trees one after another. Okay, kalau you perasan tapping knife ni, kita tak basuh setiap kali kita tap pokok getah. So from one to another rubber tree, you akan terus tap. So dia akan jadi agent untuk transfer the bacteria carrier ni. Okay, as soon as the latex is tapped, it therefore become contaminated from these sources. Okay, the pH of fresh latex is slightly on the acid side of naturally at pH 6.8 to 7. Okay, bacteria proliferate ideally in the range of 7 to 8 and at temperature around 42 degrees Celsius. The main nutrient are the carbohydrate in the serum phases. Okay, the second nutrient is the protein itself. Okay, saya cakap protein ini yang menyebabkan microorganism grow, followed with the lipids and the third source of nutrient. Thus, latex provides the right nutrient and near ideal condition for the growth of microorganism. This volatile fatty acid VFA subsequently destabilize the latex. Okay, as the microorganism process started and its grow, the VFA number will be elevated and it will destabilize the latex. Okay, hence autocoagulation in the conservations, which is due to the action of bacteria on naturally occurring sugar and carbohydrate in the serum, resulting in formation of VFA. The caplam, tree leaves, barks, and ground squirrel and polybag rubber are examples of autocoagulated rubber. The fourth one is a continuous coagulations. Okay, what is continuous coagulation? Experiment by RRIM, Rubber Research Institute of Malaysia, have shown that mixture of diethyl sulfosucyanates AOT at 0.2% weight over weight on the RC and calcium chloride, which is 0.3% weight over weight on the RC, is added to latex at pH 6 to 7, result in instantaneously coagulation. Coagulation was carried out on a conveyor belts onto one end of the latex, and the coagulants were metered and coagulants removed from the other end. The aims of the method was to eliminate the process of coagulation tank, process of coagulants immediately after coagulation. This method cannot be used if the latex pH is above 7. So ini satu lagi teknik untuk continuous coagulation. Apa yang berlaku, awak letak latex satu bahagian, bila dia lalu dekat conveyor belt sampai dekat one end, they introduce with this chemical mixture and they will what we call that instantaneously coagulate the latex itself. Okay, So apa yang berlaku bila awak buat macam proses ni, awak akan you will eliminate the use of the coagulation tank. So tak perlu banyak tank untuk coagulation process, etc. So the proses itu berterusan. Okay, berterusan. So letak terus di-coagulate. Okay, tak perlu tunggu masa yang lama. Okay, tetapi dia ada limitation, which is latex yang pH dia melebihi 7. So maksudnya during the tapping process, awak tak boleh letak any preservative. Okay. Atau awak tak boleh letak any ammonia, anticoagulants lah senang cerita. So any anticoagulant cannot be added during the tapping process because you want to use the continuous coagulation, or else this continuous coagulation is not applicable for that field latex. Okay, and then the final one is heat gelation. The latex is coagulated by raising the temperature to 80% of the heated screw conveyor. Study on coagulation process of higher rubber ABS latex. Okay, it shows some of the abstract that shows the heat gelation. Although it's not fully coagulated, it significantly gel the latex to promote eventually on coagulation itself. The procedure, the latex is sieved and bulked, followed by addition of chemical. A sample is then taken and the amount of formic acid required for coagulation is then determined by the titration of 100 grams of latex with standardized of 1% of formic acid, prepared by diluting of 10 gram commercial formic acid to 1 liter of water until the pH is 5 to 5.2. The amount of coagulant given by weight over, B is the amount of latex in bulks, which is liter. T is the amount of standardized, which is 1% of formic acids. Okay, divided by 1000, which is 1 kg. So this is the amount you need to use for the coagulation itself. So this is how you measure the amounts of coagulants ataupun acids yang you perlukan untuk coagulation process. Okay, the amount of weights is then added to the acid tank and the level of acid and latex are then equalized, after which the latex and acid valves are fully open simultaneously. When one screw is full, the down corner is transferred to the next screw until the end of the discharge. After discharge the tank, pipes and valves should be cleaned thoroughly. Okay, I think that's all for this chapter 6. I hope you learn something on this coagulation process technique. If you have any question, you know how to find me. I welcome you any question. By then, thank you and Assalamualaikum warahmatullahi wabarakatuh.